Today we are going to learn the basics of calculus, the very first thing you learn in calculus. I'm assuming that you, the viewer, know how functions work, how to do algebra. You should have passed algebra and geometry. And also know a bit of trigonometry as well. So if you know how to graph a function, f of x equals like sine of x, and you know that it's just going to be a swirly curve, then, and you also know the the formula for like the area of a circle. Well, you could just look it up, but hopefully you guys remember some of how to do that kind of junk, because that stuff is going to be useful later on. But at the moment, that's what I expect you to know, and if you don't, learn like the very basics of like trig and stuff. I really do expect you guys to have mastered algebra and some amount of geometry, remember some bits of it, but beyond that, you don't really need to know at the moment, because for the very beginning, I'm just going to introduce you to something rather simple: a limit. It's the most easiest concept. There is a form. It's just like, I don't know how to explain it other than like it's basically where the function approaches. When it's when inputs approach a given value. Now, this may seem absolutely confusing, and honestly, you don't even need to. It really is completely fucking useless, because I think it's better for me to just show you all. So the limit of some function x as x approaches some value a, I guess. Let's say f of x is equal to x squared plus 2x plus 1, I guess. And I believe the graph is basically at 1, basically. The bottom of the graph just touches that part. Basically, if I were to say what is the limit of f of x as x approaches 5, I guess. 1, 2, 3, 4, 5. Of course, on the graph itself, it sort of just yeets away, but what does f of x equal at 5? Plug that in, you get like 25 plus 10 plus 1, so you get like 36. I think I fucked up writing this equation now that I think about it. It should actually be a little bit more to the right, right? Whoopsie-doo. Let me just real quickly do that. Just to make it a bit more accurate. But that's what it equals at 46. And since I don't know how to explain, but like let me find the words for it. Basically, you basically sort of like input f 4.9, and then you continue on. You basically move on to 4.99, and it's sort of, you keep on going until you get infinitesimally close to 5. And you also do it for like the other end as well, 4.51, then f of 5.01. You're basically sort of approaching the graph wherever that is. Let's just pretend like, I don't know, we've zoomed in on the graph at like this point or whatever, like somewhere up there. And we have like 4, 5, 6, and like let's erase a little bit of this. We're basically trying to find the value as, we approach 5 here, as x approaches 5. That's what I sort of mean by that. We're just getting closer and closer to 5. And of course, you may be thinking, then why don't we just plug 5 in and get 36 out? And that is a good question, but of course that wouldn't work because, of course, we don't really have to define any graph per se, but like, say there's a hole in the graph. And this value here is like 20. This is 7, I guess. This is f of x. F of x at 7. F of 7 is undefined. This doesn't technically exist, right? But like the limit of f of x as x approaches 7 is in fact defined here, because like as we get closer and closer, we get like, we probably get like, as we approach like from 6 or something, and then we approach from there, we might get like values like 18, 19, 19.5, 19.85, 19.90, 19.975, 19.9895. You just eventually, and of course from the other end, 21.5, 21.2, 20.8, 20.6, 20.4.5, 20.45, 20.205, 20.1285. Just gets progressively closer to 20, but doesn't actually touch it. That's what the limit really does. The limit at this point, even though this here doesn't technically exist, equals 20, because that's what the values approach. And that's where it's basically like, it's a really simple concept. It's just, you look at the graph, you look at like where the thing should be, and you sort of realize that, oh hey, it's that should be, it approaches that, technically isn't there, but like if it kept on going infinitesimally close, like super close, it could be 19.999999 something, all the way to the point where it's like infinitesimally close to 7, but like at this one point, and we have like 20.0000000001 at like this point right here. We get closer and 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 closer, and that's what a limit is. We figure out what the value is sort of approaching, and yeah, that's your limit. That's the basic concept. Though there are special graphs that, you know, limits aren't defined as, but I'll just give like practice graphs for you to figure out, but it's really simple. I'm gonna expect you guys to pause the video, literally, or rather, don't even pause the video. You guys should literally be able to see exactly where the graph is going. You guys don't even need to tell me if you guys would probably pause the video. The limit of the f of x with respect to like the functions of, you know, the specific problems as x approaches a certain value. What is the limit here where when x approaches 3, the limit here when x approaches 7, the limit here as x approaches 5, the limit here as x approaches 11. Of course, I expect you guys to have not even paused the video, but of course you guys could have, but the answers is just like the limit of f of x as x approaches 3 in this function right here, it's just 7. Limit here, 20. Limit here, 69. Limit here, 2. Or I hope that looks like a 2, yeah? Not 1, a badly written run. What the hell is that stutter? As for why the limit does that, it's just what it does. I don't know what else to say. That's just what it does. Like how addition just sums up numbers together. They just add. I don't know why they add. They just add. That's how we defined it. But here's a special little function here. This proportional, by the way, this doesn't really make sense, I suppose, but this is f of x. F of x at 5 equals 6, because it's defined at this point. It's a jump. It jumped from like here to here, just straight up, but it's defined at this point, yeah. However, what do you think the limit of f of x as x approaches 5 is? What do you think that equals? What do you think it will pop out if you try and do that? Well, I mean, you guys don't have to pause the video. I'm just gonna fucking look for a good color to use. Well, I assume you guys are trying to figure it out. Yeah, I think this is a good color. So let's figure it out. What does f of x approach as x gets closer to 5? Well, you can do it from like 4 and 6 here. Can try and figure it out. It's like always 4 here. It's getting closer to 4. We keep, you know, it's 4 here, 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 4 here. Approaches 4. Okay, but what about here? You have like 6 here. And you know, it's 6 here, 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 6 here. Alright, that the limit seems to be approaching 6 here. But the limit here is approaching 4, yeah? As x is approaching 5 from 4, it's approaching 4. But as we're approaching 5 from 6, from a higher number, we're approaching 6. Of course, I accidentally chose like a really bad number, I guess, for this because it's sort of, I don't know, this technically could be like 20 and 10. Because, you know, this would technically, in this case, the limit here would approach 10, 10, 20, 20. But, like, the basic point is they're approaching different numbers. And what does this mean? Does this mean A, the limit of f of x as x approaches 5 equals 4 and 6? B, oh no. Basically means it isn't defined. You know, oh no. The limit isn't defined. Of course, I think the answer, I mean, it kind of does. Personally, it confused me, I guess, because, I don't know. You know functions like, you know, the square root of a number? Technically, you know, like the square root of x as a function, you know, it's only defined up here because, you know, technically that's how it that's how it works. But like technically, like if you square root a number, you could technically multiply like the square root. You could square the square root, the positive square root, or you just put a negative symbol before it. If you multiply it together, it doesn't really matter because the symbols would cancel out. Technically, it would make sense that, you know, like something like for like the square root of like 4 to be equal to 2 and negative 2. Of course, I don't blame anyone if anyone thinks A. That does make sense, yeah? It would sort of make sense in that sort of way. But right answer is that's actually false. The limit isn't defined at this point. It's just not applicable. And that's basically it. I don't know how else to explain it. Basically, at that jump, the limit doesn't exist because it doesn't approach a specific value. Like from one side to the other, it technically does approach a value. Like it's like, even though this here is defined, the values approach different values. The limit from one end and the other end, from numbers smaller than 5 and numbers higher than 5, they both approach different values. So like, because, you know, again, I don't know how to explain it, but like, You also can't just average it out and say like the limit of f of x it approaches like straight up 5 either, because that's like completely different. But there is a special little thing that I like to call one-sided limits. Guess we'll just do like the same type of equation, but like slightly different in value. So we have this, the bottom part is defined, but the top part isn't. We'll set this to like 7, and we have this set to 5 again. This can be set to 11. There is something called a one-sided limit. This, of course, is f of x. As x approaches 5, it's not defined. It's not applicable. It's just undefined. It doesn't approach a specific value. But we know what the limit of f of x as x approaches 5 from like a lower value, which we give like a superscript minus sign. We know that it approaches like from... We know that from here it's a 7, from here. We know that it approaches 7 in this case. And in the case where, you know, we also know what the limit is when we approach 5 from like, you know, higher numbers, which we give a subscript plus sign. You know, we know that it's 11 here, it's 11 here, it seems to be approaching 11. It's defined at that point. You know, it's defined when we go like one-sided, one way. And that's the thing that exists. Other functions, I guess, I guess that's really all you really need to know, I guess, because you could technically have like functions that jump around here, you know, you still technically define at this point, doesn't really matter, squiggly, there, and there. Of course, functions like this, like the one I showed you before, Pen just gave that little cool, wacky effect. This, I feel, I don't really know what the limit would approach as x, you know, like give this an arbitrary number. I guess I'll give this like a 2, and this is like a 4 here. Square root of x is f of x. The limit of f of x when it's like plus or minus the square root of x when it approaches like 4. I don't know how I'd really describe it, because I mean, if it's defined at the bottom here, then, you know, I don't never ask that question to my teacher in class, so I guess that's something you should ask to like your calc teacher if you ever take calculus or ask some mathematician. I don't know. I'm just a student trying to teach other students who may not be as smart as the other top students, and I'm just just helping bro out. But typically, since square roots are defined at the top, this would technically just be 2. Just be equal to 2. Typically don't consider the bottom part. I don't know why, but you know, just easier to do that, I guess. Though you could also think about it in a completely different way and try and define it such that, you know, you could try and do, I don't know, maybe something like the limit of y as like y approaches -2. or something, and we probably would get like 4 or something, you know? I typically do that. Doesn't really matter what the variables are defined as, or I feel like, I hope you guys get the point. I don't know how else I could explain it. Like, you know, you're technically approaching a singular value and stuff, and you're technically approaching it from here. Hope you guys can see through all the scribbles I just put there earlier on, but yeah. Then finally, I guess, in order to end this 25-minute video, there is a special thing, I guess. I'm just trying to teach a conceptual thing, I guess, but continuity, I guess. Special word. Interesting, isn't it? You can do, it's basically, I guess, to try and formally define it, a function f of x could be defined as anything. X, 2 squared, or not 2 squared, x squared, or 2x squared, and stuff like that. A function f of x is continuous if f of a is equal to the limit of f of x as x approaches a, where a is any value on a function. Doesn't really matter. It could be -1, -2, 3, 4, -5, 6. Yeah. So this, let's say we have this function here. This is continuous because at every single point it's sort of defined. There's no holes or gaps in it. But if there's like a hole or something, this isn't continuous. And if there is a function like this, that's also not continuous. That's like the basic formal way to prove it. So, like, this is continuous because it's complete, no holes, no jumps, but these are not continuous. That's just the basic conceptual idea of limits and how to find them and stuff. I haven't shown any real problems, I guess, besides that, like, that one little bit, but I feel like that's something I should cover later in like a practice video or whatever. But that's like how you think about limits, I guess. It is basically how you know, the limit as x as a variable or whatever doesn't really matter. Some function, it doesn't even have to define f of x, g of x, h of x, omega of x. And the variable doesn't even have to be x. It could be x, y, z, theta, alpha, beta. You know. And it just approaches a value, which, of course, is typically defined as like a, but like that's just a placeholder thing. This doesn't really, yeah, don't know what else to say. But that's just, yeah. I do feel like I'm still forgetting something, but I'm pretty sure that's all you need to know in order to remember and sort of understand limits as a whole. It really is just that simple. There are special cases and stuff, but again, like, the limit is defined when there's something. Oh wait, now I remember. Here's a little fun function that you guys probably did. At school sometime on your calculator, if you would play with them like the nerd that I am. F of x equals 1 over x. The limit of 1 over x as x approaches 0. That happens to literally, that is also undefined, but like the one-sided limit, technically as we approach it from the small one, yet we technically can write it as negative infinity, but like typically how would I put it, since infinity technically isn't a number, although it technically approaches like negative infinity, goes on forever and stuff, it's technically undefined, even though it goes to infinity and stuff. And that actually is another interesting thing as well, because let's try and do a little other fun function, I guess. If we know, like if a function approaches some value, let's just call it e, or why don't we just literally use e? You can technically define the limit of f of x as x approaches. You can have it write a limit such that x approaches infinity. And if it approaches a specific value, then you could literally straight up write, yeah. Of course, if trying to like, do a limit like where f of x literally equals x, if you do the limit of f of x as x approaches infinity, you'll straight up just get infinity. There is literally nothing special about it. In this case, it's just, what does x approach as x approaches infinity? It approaches infinity. Not that special. Really isn't that special. And yeah, that's like the very, very basics of a limit. And now you gotta sit back and remember that, if anything, I've forgotten anything specifically. Oh yeah, I guess I should probably get more details on like the continuity, I guess. I don't know. Maybe define it more. Try and explain it more, I guess. But like, at this point right here, although the limit here is defined, f of a, if this was a, this also can also, again, it's not really, it's just an arbitrary value. It could be 10 or whatever, could be 69, doesn't really matter. At this point, although the limit as x approaches 10 exists, f of 10 doesn't exist, and because of that, it's not continuous. It's just like basically, again, just a more formal way of proving it. Like this function isn't continuous. You can't just say like there's a hole in it and it's not continuous. But like, how do you know for sure? It's just basically it's just I really don't know how to explain it other than like, you gotta use the techie language in order to formally prove something as an absolute fact. So you can't just say this function isn't continuous because it literally jumps right here. Can you not see the giant gap? You have to say it's the limit at a doesn't exist, even though f of a exists, or like f of a doesn't exist even though the limit doesn't exist. Though now that I think about it, I'm pretty sure that if both f of a and the limit as x approaches a of f of x don't neither of those exist, I'm pretty sure that also means it's not continuous, but technically they're still equal. I don't know. Ask a teacher that, but I'm absolutely pretty sure that also means that it's not continuous and stuff. I don't know. You have to use a stupid formal language and all these techie proofs in order to prove something, because otherwise you just straight up get an F in class. Yeah, no, and just learning stuff on the internet isn't enough for you to get past the test and get free college credits and stuff. You gotta actually know like how to do proofs and stuff and do a whole bunch of other wacky stuff, which is an entirely annoying and a waste of money and time. But I don't know, just that's what you need to know in order to actually get through and stuff. I don't know. This might be useful for like writers and stuff who don't really want to learn calculus and junk and just want to know enough calculus to flaunt, just brag about to their friends. Oh, hey, I know what a limit is. It's like the first thing you learn in calculus, man. Trust me, I'll make sure you can flex on your friends when you guys can start integrating the surfaces of multivariable functions and crap like that, okay? You'll get to flex at that point. But calculus isn't actually that big of a deal. It's like the simplest thing. This limits are like the very, very beginning, the start. And I promise by the end of this stupid thing I plan to do, I'll make sure you guys will be able to flex on other people with your huge math skills by making them do integrals and line integrals and figuring out the curl and divergence of a vector field. Yeah, no, this isn't just going to be like regular calculus. I'm going to try and move you up and trying to make sure you guys eventually get to the point where you guys can understand multivariable calculus. So, I hope you guys sort of understood this. Please leave questions in the comments section, because I'll definitely go through them, try and explain stuff. Please also correct misinformation, because I am pretty sure I dropped a lot of it, especially because I'm just a regular dude. I'm not even a teacher. I haven't taken an education or any how to teach and stuff. I don't even have my notes out. I'm just doing this straight from the memory. But yeah, hope you all enjoyed. I feel like I've repeated that already, haven't I? I'm dumb. Anyways, have a good day. I said that again, didn't I? Bye. Fuck.